Right now, millions of people are using supercomputers in their pockets to scroll through short-form videos. But in labs across the world, scientists are building technology decades ahead of what most of us can comprehend. Nikola Tesla was famously known as the man who invented the future. Yet, for all his brilliance, he died practically penniless, leaving his grandest visions unbuilt and untested. For over 100 years, critics have pointed to his unbuilt concepts, like atmospheric energy grids and advanced propulsion, labeling them the impossible fever dreams of a mad scientist. But imagine if Tesla had been born in the 2000s. Imagine giving him access to machine learning algorithms, to quantum computing, and a global internet connection. The common view of Tesla's failure misses the mark. His engineering wasn't flawed. He was simply an outlier born into an era that lacked the physical infrastructure to catch up to his math. We can call this the infrastructure bottleneck. It happens when theoretical science races far ahead of the physical materials available to build it. In the late 1800s, Tesla was trying to execute advanced theoretical physics using nothing but rudimentary copper wiring and weak chemical batteries. If you remove that bottleneck with modern components, the math begins to work. Erase those historical limitations, and the timeline of human civilization shifts, bringing concepts once considered science fiction into immediate reality. Take the Wardenclyffe Tower, his ultimate attempt to transmit energy wirelessly across the globe. The engineering constraint in the 1900s was extreme. Grid transmission and storage were so primitive that sustaining power required for atmospheric conductivity resulted in catastrophic energy loss at the source. Today, we have high-capacity solid-state batteries and smart grid controllers capable of sub-millisecond frequency tuning. By applying modern phased array transmitters to Tesla's theories, we can maintain the specific terrestrial resonance he required. This stability transforms a theoretical atmospheric channel into a viable energy highway. This precision solves the energy loss problem that defeated Tesla, putting a wireless city grid within our technical reach by 2026. Beyond materials, consider his workflow. Tesla spent years doing complex physics calculations by hand and constructing physical prototypes just to test a single variable. Now drop those same equations into modern quantum computing and artificial intelligence. They act as timeline compressors. AI can simulate millions of aerodynamic and electromagnetic models in a fraction of a second, bypassing the need to build physical machines just to see if the physics hold up. By using AI to automate safety validation and material stress testing, we condense decades of manual R&D into a single afternoon. This makes the blueprints for Tesla's vertical takeoff crafts viable for manufacturing today. And then there was the human element. Tesla struggled intensely with isolation, constantly failing to make traditional financiers understand his non-traditional concepts. The internet provides real-time global data, instant crowdsourced peer review, and a direct line to audiences eager for innovation. Access to a global network of peers eliminates the isolation that allowed financiers to stifle his work. The internet serves as a persistent, real-time feedback loop for his most complex theories. Put all of this together, and the alternate reality of 2026 comes into focus. It is a world where the power grid, with its millions of miles of vulnerable physical cables, is obsolete. With advanced energy systems integrated into daily life, everything from urban planning to global shipping pivots to rely on boundless, ambient power. True innovation requires both a visionary mind and a technological ecosystem capable of supporting it. There is a profound irony in Tesla's timing. He was a man who essentially conceptualized the 21st century while living in the 19th. While we are currently focused on advancing machine learning, processing power, and global connectivity, we are just now finishing the exact set of tools Nikola Tesla was waiting for essentially.